Thank you for coming. My name is Hassan. I'm recently joined Microsoft as a cloud solution architect. Before that, I worked in various different companies in different domains, from payment to logistics to e-commerce and so on. So today's talk is about resilient engineering. When I prepped for this, I thought I'm gonna go ChatGPT, Google, and find definition of resilient engineering. But actually, what come back to me is something that an IT director of a logistic company that said to me a long time ago, and it's stuck with me ever since. And what he said was, in our business, the IT department, no news is good news. And I think that somehow, for me, capture resilient engineering in that essence. So in order to talk about resilient, hopefully the clicker would, there they go, there you go. And I think it's good to put that into some context. Hence, Furball Limited. This is generated by ChatGPT, actually. So Furball is an e-commerce company that's selling Furball in an animal kingdom, and there are two characters: the CEO bear and a solution architect foxes. So what we will do is go through, revisit their kind of the current architecture state that they had at the time, and going through their journey to building a bit more resilient system. As any story, any disclaimer, the solution that's proposed in here, one of the possible solutions, might not be the best one, so any recommendation, suggestion is much welcome. I also want to call out, if this presentation is good, then credit to John. If it's bad, it's because of me. Right, okay, so bit of a context. So this is the current architecture state, Furball Limited. So a typical e-commerce, Furball got an app and a website which allows the customer to browse and add the item and then purchasing. They have a warehouse. We stock the item, carrier to then ship the item, and now the third party to do other stuff such as payment, finance, etc. All of their workloads are hosted in a single data center on-premise. So as you can see, there's a lot going on here, and even this diagram do not represent everything that happened within Furball Limited. However, a couple of things to call out: all the API or the workloads are either running on IaaS or Windows services running on VM. In the center of that is a SQL database, big fat one, and is a part of kind of integrations, and that is basically the center of the business. So just to call out a few flows. So when they receive the item into the warehouse, this is not been sold yet. This new item they come into the warehouse. They send stock data into a SFTP location. Stock will then read that data and then write that into the SQL database to make it available. So then the customer can then see the item and then going through the customer journey. When the customer adds it back, back services will then call to stock again to create the allocations. At the point of purchasing is the orchestration between back, payments, and order to do authorization, settlements, write the data, and send the order file. So I'm not going to go into detail exactly how all of this link together, because I think what I want to call out in here is there's some problem with this particular architecture. So obviously we have a central SQL server right in the middle of everything. And we have a lot of problems on SQL performance. So the typical Black Friday, Cyber Monday, Boxing Day that happens, we have a lot of that latency in the system. But interestingly, to call out, even on a non-sale day, sometimes we observe SQL performance as well. And one of the typical use case was, so when we have a lot of stock intake in the warehouse, which in turn creates a lot of data from the warehouse back into the on-premise services, stock will then do a lot of write into that SQL database and then caught the operation off guard, because they don't know when the trailer arrives at the warehouse, which then incurring a lot of write into the database. So that is kind of the operation problem with this particular architecture. however, I want to call out things that are even more severe for the business is because of these particular constraints, release taking very long. So all of these running on the VM, there's application dependency on this VM, and therefore, and the release to SQL in this particular architecture is become a scare thing for everyone. The QA time takes such a long time, and actually that slows the velocity of the business, and the business cannot deliver a feature and competitively to the market as soon as they would like it to be. Still, everything's still hanging, business still trading, all good from the business concern up until, if we can click that. Oh, I'm not going to do that. Here we go, do that one. Right, so landing spry, literally. So we have CEO Bear come to Fox and say, oh, we have a problem with our data center. It's been hit by landing strike. It took us 4 days to be back online. What can we do? And the current and Fox say, well, what does the current provider say? Well, they propose as another site with actually a contract. We're not sure this is what we want to do. And we suggest, then the solution Fox suggested, well, we should move to a wallet Azure and take advantage of the cloud and only pay what we use for. This conversation in real life is not as simple as that. Okay, so at this moment in time, the confidence of Furball Limited to the provider is very low, right? And also the scare of single point of failure. The single point failure here is the provider themselves. And also in terms of the strategies of where the company want to go, they want to be a global business, and therefore they would like to expand into different geolocations, US, MENA, and so on, which the current provider do not offer. And they also don't have capability in terms of different areas such as AI, machine learning, data warehouse, etc. Right, okay, so moving to Azure, okay, sounds good, right? Will that help improve our system resilience, okay? So, well, okay, resilient, let's try to understand that first. So let's say if our system is down and we cannot take the order for 1 hour, what's the impact and what is the cost for us? And as quickly as you can tell, CEO Bear come back and say, well, the cost will be millions. And does not include any reputation damage, which we just experienced for the last 4 days. Well, okay, so if we can build a system that recover within 5 minutes, but it's gonna cost X amount of million, is that okay? And then the business or the Bear, they say, well, okay, we can tolerate probably about 15 minutes if the system is not available, but ideally it's not, okay? And people say, okay, because we'll always try to minimize the downtime if we can, right? But we can tolerate 15 minutes. Again, if this conversation is that quick in real life, that would be great, right? But no, in practice, it's a very long and hard conversation. And the reason is business does not understand the resilience. What does that mean? The conversation is always work, right? It should always work. All right. So I think there's a few challenges to it. So just to cover a few things. So first is to understand the impact and how do we assess that to the business. And it take a lot of time for folks to go around the business and then try to talk to different domains and to understand it. And what folks would have found is different domains will think about it and then assess it differently. The only thing in common though is everybody thinks they are the most important. Right, so it took a long time to then try to get the business to think, right, okay, which one is really important? Is order intake is important, warehouse operation is important, or even finance reconciliation is important? It took a long time. Eventually, we understand it's not the same across the business. Therefore, some classification is then required, which then comes next to the challenge. Okay, so now you can have a tier system like mission critical, etc., etc. Try to establish what is acceptable become another challenging, because this is the balance between cost, complexity, and the resilience is going to offer. the business going to demand the world, but it's going to cost X amount of time, efforts, and so on. At some point, there will be intersection between the cost and the benefit they provided. And to understand that where is that intersection for each of the classification, it is very important. Right. So once the classification is available, which is together with the guidance that have to move the conversation forward. The second thing is think about the cloud, and the option is now available in the cloud that require various different thinking. As you can see that before, the infrastructure is fixed. They've got a set of VM, they've got a SQL server. When we talk about the conversation, it's all about, okay, can we buy a new machine, add them in, make it more resilient, conversations. But on the cloud, there are new questions, new opportunities available, and then to hope, and then try to have that conversation within the business to help them to understand is very important. Things like global routing capability, ability to scale up and out, and so on and so forth. All right. Okay. So business is happy with that. Want to go on Azure, but we want to move it as soon as possible. All right. But we still want trading. And not all of our area business can move at the same time. Everybody have their own thing to do. They have their own initiative. They cannot move at the same time. And it's, in practice, it is very it's very unlikely. I'm not sure if anyone here have a chance to work on a project where you say, okay, we're going to do deployment we're going to move every workload onto Azure, and then one day just switch it over. I'm not sure if anyone have that privilege. So that actually impose to folks to say, okay, we have to find a solution where part of the system can be moved to Azure, and then the other parts still stay on-prem. So the initial proposal was something along that line. This is more like a pattern rather than the actual architecture. So the idea of this is introduction of the message bridge service, where messages can be sent from the on-prem data center to the Azure workload, whichever is going to be moved to Azure. This will help reduce the dependency between moving each of the workload into Azure, because each of the team can just move and then they just receive the message on-prem, wherever on-prem is. However, there's a bit of an issue for that one. The issue for that one is a composite SLA. So the composite SLA for this particular is a composite of all the components within this particular design. And the composite for this particular three workload, three component I pull out here is 99.88, which allow about 12 minutes of downtime every week. So it's not great for a business that will want to be global. So a bit of a caveat, not all components is involved here. So things like monitoring, secret like keyboard and anything is that is not even included, and so on and so forth. So Fox needs to address these problems. And come back to the previous incidents where landing straight into a particular region or data center. We want to deploy that multiple region. And there are a lot of conversation about standard or premium SKU, which pattern, type pattern do we follow, active or active passive. And this is kind of the pattern and average. So we follow with the active patterns and with the event store on Cosmo. So what happened is when the message bridge send the message to the Azure workload, Azure workload is deployed into multiple regions, and there will be two Azure Service Bus namespace in each of the region. Message bridge will then send the same message to the two Azure Service Bus namespace. And what we do is the workload will then write that into the event store in the Cosmos, which then got replications from the primary region to the secondary regions. So imagine the first message going to this workload, get written into the event store, that message get marked complete. The same message get into the second workload, and then this workload will then hit the event store again, and it will see that, okay, this message already been in the event store, and then it mark that message to be completed. Yeah. So the complexity of this SLA, this portion is now 99.98%. That is a much improvement compared to the 99.88 before. Yeah. So a couple of things to call out in here is you can see that there's a white line to go to the primary region, right? Okay. So this particular implementation was implemented when Cosmos didn't have the multiple line functionality. However, even when Cosmos make that feature available, we did some testing and we found out, okay, given that we have the system, the managed failover feature, and that if it's enabled, then all the workload can be transparent and then failover, and that was still within the RTO that we define for that particular service. So therefore, these implementations still stay as it is. Okay, so right, started and not stopped there. Right, so we going on a journey. Stock has recently moved to the cloud. However, there's a problem with the database. Whenever stock arrives at the warehouse, remember that? That's still happening. All right, okay, so we explain, so Stock explained that to that and say, look, it happened because of when we have many files on the warehouse, we tell product about it. Because every time we increasing the quantity change, etc., we tell them. So then they have the latest stock position. Right, okay. Wow, and they say, well, isn't that a good thing, right? We keep our stock up to date, right? We present the customer with the right stock quantity. And the stock said, well, not all the time. But exactly we show it to the customer a checkout or on the browsing journey, right? Do we show the quantity or not? Well, we just want to show the item is running out of stock, something that's saying running low, not a number, right? And therefore selling fast. Okay, so we established that we don't need to update the stock quantity all the time then. And once we discover that, then obviously there's a solution for it. So as I said, stock has already moved, but product at that moment in time still sit on frames. Then the solution is, okay, stock can then send the stock update to the product that still sit on frames only when an item has an next item. So these solutions are relatively simple to implement. However, actually, this actually call out, this solve the performance definitely for that, because then the quantity of the message that we're sending to the on-frame significantly reduced. But I think this one is bring me to the point I would like to mention about domain-driven designs. What is called out for me here was, okay, so we can model stock and product differently, right? Because in stock, quantity is important. Number of items in the stock is important. But in product, well, you don't. You just need the state of the stock. I think that's all you care about. Yeah. And the domain understanding is a key to making that decision. And that leads to other opportunity when we understanding the domain, we can make the decision when the art, to understand what is the art of the possible. So we can make the configurations on, which item do we want to tell product that is running out of stock, because not all items are treated the same. So highly touted product like Nike trainer recently came out, high value. They have a different character to just a normal sock, right? Sock is normally everywhere. And I remember one of the business I work with, their test item is always the socks because they're always available all year round. Yeah. This is not a particular and restricted to this particular use case. We can also make decision about warehouse and order management. So, for example, the warehouse send the order file as soon as we complete the settlement of the payment. But is that really the case? If we have a standard order and a next day order, which one do we prioritize? To understand all of that within the domain is quite key. I'll come into that in a minute. But another example, does it mean that we reduce the integrity of the data every time? Not necessary. So an example of that is traveling. So when the travel agents do the booking, do they always book to the exactly number of the seat on the airplane? I think they kind of well know that they don't. They always overbook it to a certain degree, and then hopefully someone cancel. All right. So great, the business. Okay, now they're talking about RTO, RPO now. That's great. So we have agreed on what is meant by an RTO and RPO for each of the classifications. But what does that mean when the stock went down? Stock service is down. Right? We moved to Azure. We're supposed to have resilience, right? Well, we agree that we have 15 minutes. So therefore, if the stock service went down, that means customer cannot add to back for up to 15 minutes, right? Okay. Now it's what? Okay. But we said, no. We don't want that. What else can we do? We don't want to not taking, even when the stock is not available, a stock service is not available. We still want to be able to allow the customer to add to back. Okay. So therefore, we have to find a way to deal with temporary outage. Fox will then came with this kind of a solutions. So at this point in time, Bags has moved to the cloud. So the solution is when the client calling to the BAT API to do ActiveBack, normally BAT will then call out to stop and then add or remove the item or reserve the item and so on and so forth. However, BAT will then implementing retry and circuit breaker policy. And then when it's realized that, okay, stock is down because of whatever reason, it will then short circuit that. It will then send a message to its internal Azure Service Bus. And then there's a worker that basically listen to it and then basically do the retry, the add and remove spec operation at a later stage. And the key thing for that one is it is important to allow the customer add to back, and in the whole eventually will make the state in the back exactly what the customer see at some point in time. Yeah. And this actually call out to another important topic is health modelings, because then basically if we can understand what is the journey, not all journey is exactly the same problem, and therefore we can make appropriate design decision to protect that. Right, okay. So that's the next one. The next story. Right, okay, so now the customer can add to back, even when the stock is down, it's great, right? We then have facing another problems. So many customers tend to cancel as soon as they place the order, and it's costing the warehouse and finances. So every time we do a transaction, we have to pay authorization fee to the card processor. When we do a refund, there's a certain fee to go with that. Okay, so from the business perspective, a cancellation means we lose money. Okay, if the order file has been sent to the warehouse will then start picking and processing them, right? And they normally don't stop, and then they want to send them, and then the customer will then return them, which is another occurring more cost. The reason for this one is actually Furball doing a very good thing. They offer free delivery. Who here got Amazon Prime? There you go. So if you have Amazon Prime, I'm not sure you have the same behavior like I do. I place an order, I just add to back, place an order, and then 5 minutes later, I have another one. I go and place that order again. So that is because of that proposition in terms of delivery, that trigger these particular customer behavior. Right, so we then pose the questions. Right, oops. So Pop will then say, okay, Pop will then say, right, but do we then have to send the warehouse the order straight away, right? Well, the answer is no. So for example, if you, as I mentioned before, if you have a very long lead time order, you can hold it for a bit longer. But if it's next day or even sometime instant, so Amazon in London, you can have delivery next day or even in the next few hours. Therefore, that order should be prioritized going out first. International order normally have a lead time to 4 to 5 days. You can hold it for a day, not really a problem. So the answer is yes, right? There's not many order have to relax this time. You don't need to do that, and therefore, okay, we might have a solution for that. So, what does that look like? I do apologize for not having a nice, beautiful Azure diagram, but I think this is useful to represent the solutions. So these take advantage of the Azure Service Bus schedule message feature. So it is very simple. It's when order will then trigger a message to order events, and the message is scheduled delay for X minutes. Now this X minutes is configurable for certain business logics. I say standard is half of an hour. I think next day is 15 minutes. But during that 15 minutes, customer can then cancel the order. The order hasn't gone to the warehouse yet. No cost, no billing, no settlement has been performed just yet. So from the business perspective, they haven't lost any money just yet. Azure Service Bus, in this one represented by the order of the event, hold the message for X amount of minutes and then set it down to downstream system when X minute has been passed. Relatively simple implementations, but it works. Yeah. Right. You can probably guess now. Fox have more problems. Now, great. We have sale coming up. Another Black Friday. We have moved to Azure. And the last year we have a problem with the stock database, and customer didn't like it so much. So every time we add to bag, it takes a few seconds. If you actually one of the retailer H&M, anyone who purchased from H&M, and you will see that the time taken to add to bag in H&M is significantly higher than, let's say, the Next or the ASOS, because of a particular problem that they have. I'm not going to that one, but anyway, they do. Right, so the reason is because the current solution have a bottleneck, right? So Fox say, okay, we could redesign the system to address these problems. Well, what will the business say? How long does it take? It will take about X sprints. Doesn't really matter what X said. It's too long. What else can we do? Right. Okay. Well, what else can we do? Right. So, well, we can take the order and tell the customer later that we don't have the stock. Right. So remember, we know the sale coming, right? We just get lots of stock into the warehouse. What is the chance that we run out of stock? It's lower than a normal operation. That's a conscious decision. Okay. Exactly that. So there you go. We have lots of stock, so there should not be a problem there. Okay. So there's something that we can do with that. So there we go. A bit more elaborate diagram. So the key thing is, so come back to the before bag normally call add to bag to stock to make sure that they reserve the item. In this implementation, stock will then short circuit that and just say, well, okay, no reservation will be created. I'm just going to return 200 success for you. So the customer can always add to bag. Which in turn, when the order has been placed, order file that come into the warehouse through the SFTP server. When the warehouse realizes that I don't have enough stock for this particular order, send it back to the business. Order trigger either a full cancellation or partial cancellations, and then send a message to the customer com, and then basically send an email or a certain communication to apologize to the customer. Sorry, we can't fulfill X order that X item that you order. So the few things to call out: this maximum customer intake with some no caveat. And actually, this is very important because customer acquisition. So in Furball, the Black Friday, the Boxing Day, the Cyber Monday is an opportunity to acquire new customer, and therefore they try their best to offer customer come in, place an order with us. Now, once you know your detail, We can hopefully try to have a continuous business and so on and so forth. And this is a conscious decision. Business have made a decision to trade off a certain bit of the customer experience in return of the order intake. And that is a conscious decision that business has made. These actually open up future opportunity. So because of all of these solutions combined, where delayed of the order and order now can be sent to the warehouse in batch, these actually allow the warehouse to make a conscious decision on optimizing where the fulfillment can be made. So imagine you have multiple warehouses in here. That decision now can be made a bit later. And the story go on and on. New problem, come to Fox. Fox will then propose a solution and so on and so forth. Yeah. So I was allowed to 30 minutes. I'm on 32. So what Fox has learned? What Fox has learned is resilience is a very challenging conversation. It's long, it's hard, but it's worth having. Having defined SLA RTOI is important, but again, customer experiment is the key. There are trade-offs everywhere, but it takes a long time, conversation, and digging to work it out. The outcome of all of this implementation is a lot of million-power trade cell, much faster release, because there's no dependency on a single SQL server anymore. Performance concern is now localized because they have they go to microservices, they have separate data store, etc. and etc. Come back to the last point. Yeah, so as long as bear don't get caught by fox don't get caught by bear, I think is a good news. And that's it for me. Thank you very much.